Hello, welcome yet again to another session for our mathematics live class. Now, as we began in the early part of this week, precisely on Tuesday, you have seen that we have been taking processes relating to past question reviews. That is, picking questions from our list of past questions and then providing solutions to those past questions. We were able to complete as many as 5 sets the last time out. We would continue exactly from where we stopped the last time around. Remember, this question picking pattern that we have decided to use allows us carry out practices on a wide range of subjects at the same time. So we had, in our last class, we had practices on number basis, we had practices on indices, we had practices on logarithm, we had practices on surd, we had practices on basic expansions, as well as practices on set theory, Venn diagrams, and so on and so forth. Today, we would also be considering practices on wide range of subjects as well, wide range of topics, following that same pattern we had in the last meeting. Now, of course, the pattern still remains the same. We will be using 5 sets. We will be using 5 sets, and in those 5 sets, we'll have the first 4 I'll solve, and then the 5th one, I give you 20 to 40 minutes to attempt them. Beautiful. This is exactly the same pattern we are going to be using for the session today without any fail. So let's get right into the business of the day. Again, we have sets of 5, 4 questions I answer at its range, and then the 5th question I give you as practice. Of course, we are still going to be looking at the answer together, but then it will also help you get involved with the process and as well as allow you carry out the practice on the go. Now, of course, this question bank repository that we are using for solving these questions or solving these topic questions from this subject and for every other subject that goes on our live classes comes exactly from our website, www.yourstudypart.com. On there, you'd have our lesson videos, the live classes, the mock exams, which is a simulation of what you would expect in your Jamb exam. We have a whole host of content for you in order to keep your preparation up there with the best. Now, let's begin the session for today quickly without wasting so much time. Now, first off, we'll begin with simple interests. So let's have our first question of the day. Calculate Okay, so this is our question. Calculate the time taken for 3,000 naira to earn 600 naira if invested at 8% simple interest. This is our question. Now, what exactly does this mean? We have to bring out the core concepts. Of course, nothing is much more important than the term that we are going into simple interest. So if you are going into simple interest, it will hurt us to first and foremost start with the formula for simple interest, which is PRT over 100. Okay, we have this down. What are we calculating? The time taken. So it means that the very first thing we do is to make T subject of the formula. All right. So cross multiplying, let's put that here. You have 100 SI is equal to PRT. So T will simply be equal to 100 SI, which is the simple interest divided by PR. That's a simple subject of the formula. Now, let's put in the parameters we have. What are the parameters? This is the original capital invested. So that's the principal. Then this is what was earned. That is the simple interest. And then this is the rate at which this simple interest was earned. That is the rate, 8%. Now, of course, last time out, we talked about the fact that the reason why the simple interest has the formula divided by 100 is because of the fact that the rate is in percentages. We talked about it extensively. Now, let's plug all of this in. We'd have that the time taken will now be 100 multiplied by 600 divided by the principal 3000 multiplied by 8. And now, of course, 2 zeros will cancel 2 zeros here. 1 more 0 takes care of a 0 here. 3 takes care of 6, leaving 2. Would have 2 times 10, which is 20, divided by 8. And of course, we have to bring this to lowest terms. Let's put it in fraction form. So we have this as 2 whole number 4 over 8. 2 whole number 4 over 8. And then, of course, remember, just as we said in our last time, whenever you have a mixed fraction where this part of the mixed fraction can still be brought to lowest terms, bring it to lowest terms. So this divides here 1, this divides here 2. So you have 2.5 years. Final result. Of course, just as we mentioned, you can either divide it to lowest terms here or divide it to lowest terms here. I assure you, you will obviously arrive at the same answer. So it means that it will take 2.5 years for 3,000 naira as capital to provide an interest rate of 600 naira if it is invested at 8% on that simple interest. Okay, that gives us the first solution for today. Of course, remember, we are piecing out the process step by step so that it's easier and clearer for us. However, you'd find out that most of these processes are something that you can easily jump and do some mental maths on your own. Okay, let's go to the second question of the day. If y varies directly as the square root of n and y is equal to 4 when n is equal to 4, find y when n is equal to 1 whole number 7 over 9. Okay, so this is our question. If y varies directly as the root of n and y is equal to 4 when n is equal to 4, find y when n is equal to 1 whole number 7 over 9. So this directly, without fail, is in fact a variation question. Not just a variation question. This part of the word problem tells us is a direct variation problem. So direct variation has keywords like varies directly, or sometimes you see it as directly proportional, or you just see it as proportional. Those are direct variation terms. So you should get yourself familiar with those terms as well. So let's see what this has. If y varies directly as the root of n, we are saying that y varies directly as the root of n. This is the proportionality symbol. We need to remove this symbol and bring in the equality sign. That will give us y is equal to, remove this, bring in the equality and a constant of variation, which is k. So this is the variation equation here. Now let's put in the values. This first set of values that are given is so that you'll be able to find the constants. Once you plug in these values, you see that the constant easily becomes found. So if y is equal to 4 and n is equal to 4, what does that mean here? It means that first and foremost, k by summary of the formula will be equal to y divided by root n. So plug in these values, you now have that k is equal to y, which is 4 divided by root 4. And root of 4 is 2, so this is 4 over 2, which is essentially 2. So it means that the constant of variation here is in fact 2. Now, let's find y. If n is equal to 1 whole number 7 over 9, we need to find y. Now, let's first and foremost help ourselves out by turning this first and foremost into an improper fraction. This is the same thing as 16 over 9. Okay, 16 over 9, and we know that k has been gotten as 2. We need to find y. Do not forget, y is equal to k root of n. So that will mean that y will be equal to k, which is 2 root of n, which is in fact 16 over 9 in this case. So we are using the parameters given to us to evaluate. And this will be 2 times square root of 16 is 4, square root of 9 is 3. 4 over 3. And what does this mean? It means that y is simply equal to 8 over 3, which is good enough. However, if you feel like, okay, you are given this in mixed fractions, then you can also turn this into mixed fractions, and you have 2 whole number 2 over 3 as your final result. So whenever n is 1 whole number 7 over 9, the value of y will simply be 2 whole number 2 over 3. Very straightforward, simple and straightforward. So we have that to be our result. So you see, we are picking every single concept, and you'll see that it follows through with the topic description it is. So we have seen, we have added new topics now. Of course, we have looked at simple interest, and just now we just finished looking at the term direct variations, which is very, very lovely. Now, let's pick our third question of the day. Beautiful. So we have to find okay, so the question is find the remainder when x cubed minus 2x squared, interesting. Yeah. When x cubed minus 2x squared plus 3x minus 3, okay, is divided by x squared plus 1. Okay, that's good. So this is the question. We have to look for the remainder. So whenever you have polynomials, so these are termed polynomials. Polynomials is the general name we call algebraic functions. When we say polynomials, we are talking about algebraic functions that have highest powers of 2, 3, 4, 5, and so on and so forth. When the highest power is 2, we call that polynomial a quadratic expression, or a quadratic equation if there's an equality. When the highest power is 3, we call it a cubic equation. When the highest power is 4, it goes quartic. When the highest power is 5, you have a quintic equation, and so on and so forth. And then when the highest power is just 1, you say you have a linear expression or a linear equation. So all of them are part of the family of polynomials that we know. So how do you divide? When you want to divide polynomials, the easiest, straightforward method to use is the method of long division. The method of long division. So the divisor, you are dividing by this, so the divisor comes outside, and then the value being divided goes inside the division symbol, like so. Okay, so we are dividing this by this. Now, how do you divide? You pick the first term on both sides and you divide that. So x cubed divided by x squared, right? X cubed divided by x squared. Now, of course, you can simply do your indices fast off, and you know that this is simply the subtraction of powers. So you have x left, simple, and then you have x cubed divided by x squared will give you x. Now, the next thing to do is use this x here to multiply every single thing on this divisor part. So x times x cubed, x times x squared gives you x cubed, x times 1 gives you x, and then you subtract. Now when you subtract, what do you notice? This will cancel out, which is the goal in the first place. Minus 2x squared will return because it's like saying plus 0x squared here, so it's still going to return. Then you have plus 3x minus times plus, that's minus, plus 3x minus x, you'll be left with plus 2x. Then minus 3x plus 0 or minus 0, you still have minus 3. Does that make sense? You have x cubed minus x cubed, that's 0. Minus 2x squared minus 0, because there is no, it's just like say you have plus 0x squared and you have plus 0. So if you were to complete it. So minus 2x squared minus 0x squared, you have minus 2x squared. 3x minus x, you have 2x. Minus 3 minus 0, you have minus 2. That's also what we are saying. Now, pick this larger term and use it to divide again. So minus 2x squared divided by x squared, you have minus 2. Then you multiply again, minus 2 times this. So you use the new value to multiply all the divisor. Minus 2 times x squared, you have minus 2x squared. Minus 2 times plus 1, you have minus 2. And then you subtract. So again, this will cancel. 2x will return, and then minus 3. Minus times minus gives you plus. Minus 3 plus 2 gives you minus 1. And then you are supposed to use this term to divide this. But then you'll notice what? 2x now is a value that is lower, that is the highest power here is lower than the highest power on the divisor. The moment the highest power here is lower than the highest power on the divisor, you stop your division process. That means at that point, your division process has been completed. So what does that mean? The values on top is called the quotient. And the value left at the bottom is called the divisor. Sorry, not the divisor. It's called the remainder. So quotient on top, remainder below. So we have to look for the remainder when this is divided by this. So the remainder is simply 2x minus 1. And that simply answers the question. Simple and straightforward. Now you might wonder that how exactly would I write this division if I were to write it out? Maybe for the sake of theoretical purposes. Then it means that if I take x cubed minus 2x squared plus 3x minus 3 and I divide it by x squared plus 1, it will simply give me the quotient x minus 2 plus the remainder 2x minus 1 divided by the divisor x squared plus 1. This is what you would have. In fact, methods like this is very, very important when you come across concepts like partial fractions. And then you want to express a partial fraction of a term like this. You'd find out that in partial fractions, when the numerator has a higher power than the denominator, you are always advised to carry out long division first. And the long division, what it does is reduces the power of the numerator by extracting the quotient and leaving the remainder. So the remainder becomes the power. Think about it as if you are just converting an improper fraction into a mixed fraction. That is simply what you have done. Remember, and it might look so strange, but it is. When you do 5 over 2, you say the mixed fraction is simply 2 number 1 over 2. But when you say 2 number 1 over 2, what you are simply saying is 2 plus 1 over 2. This is what it means. So it is the quotient plus remainder over the divisor. That's just it. So when you do long division, always have it at the back of your mind that, okay, we are just converting an improper fraction into a mixed fraction. And you would have yourself with the simple answer coming out. So the remainder is simply 2x minus 1. That answers our third question of the day. Beautiful, beautiful. Let's move on. Let's go to our fourth question. Number 4. If okay, so this is the question. It says if log 4 to base 10 is 0.6021, evaluate log 4 raised to power 1 over 3 to base 10. This is the question. Very straightforward, actually. So we begin first and foremost with what we are asked to evaluate. As we evaluate log 4 raised to power 1 over 3 in base 10. This is a common log. Now, first and foremost, this is what we have. You might be wondering that where exactly are we going to be able to apply this? Okay, don't worry too much. But first off, we can apply the law of logarithm on this guy. Law of logarithm says if you have the number in such a way that it's an indices, then the topmost power of that number can be split out. And if we do that, we'd have this one coming to multiply the log at the back, log 4 to base 10. And what happens? The moment you do this, we have our simple answer. Look at this. It's exactly this guy. So it means it can be replaced with this guy. So you have 1 over 3 multiplied by 0.6021. And at this point, you don't even need a calculator to divide. You just have 0.6 divided by 3 is 2. 0 divided by 3 is 0. 2 divided by 3 is still 0. And then the 2 comes here. So 21 divided by 3, you have 7. And this would be your final result. So 0.2007 is the result for log 4 raised to power 1 over 3 divided by 10. Of course, if you don't want to divide it yourself, you can always use your calculator to divide at this point. Very straightforward. Now, we have completed 4 questions already in this class. let's have our fifth question, which, as we mentioned, is going to be a question you are going to provide first an attempt, and then we'll see exactly what you have at the result. So let's have number 5. Let's just write it here. Simplify. Okay, so this is a question. You have to simplify root 5 multiplied by root 147 minus root 12, all divided by root 15. You have yourself 40 seconds to attempt this question. Attempt it. Let's see the result you come up with. Your time starts now. So, question, how exactly do we solve this? The very first thing, and the most important thing, in fact, to do for this question is to first and foremost reduce this short form. So how do we do that? We pick, this is the question, root 5 into root 147 minus root 12, all divided by root 15. And then let's bring in our values. We'll have this to be root 5. Now, I can break this down. 147, in fact, remember what we said. Every single value will reduce to a number in the first 10 numbers we have. So, root 147 can be broken as root 49 times 3. And then root 12 can be broken as root 4 times 3. And then we'll divide by root 15, which we'll just leave like that for now. If you have a need to break it, we will. And then let's bring this here. We have root 5 into root 49 times 3. We can break the root. So if we have root 49 times 3, it's the same thing as saying root 49 times root 3. This is the same thing. So if we talk about this, then root 49 will simply be 7 multiplied by root 3 minus, the same thing applies here. You have 2 multiplied by root 3, and then you have this as root 15. So at this point, what would we have? We'll have it to be root 5. Multiply these two together, or so else compare them or bring them together. You have 5 root 3 divided by root 15. And then open the brackets. What would you have? You have 5 root 15 divided by root 15. That's root 5 times root 3 gives you root 15. So this cancels out, and your final